The directions say how many triangles are possible. All right, so here we go. So this is 100. Now you got to really pay attention to get things labeled correctly. All right, now let's just suppose we found this triangle out there lying in the hallway. It's possible. What would you do with that? Would you do the law of sines or the law of cosines with this problem? This is a cosine problem, isn't it? All right, so let's step back a minute and remind ourselves, when do we have an issue with possibly more than one triangle? When I do the law of cosines? No. When I do the law of sines and find an angle. Kids, the only time you have an issue, now this is really important. I'm sorry I didn't make this clearer. The only time you have an issue is when you set up your law of sines and where is your variable?
The bottom. Oh wait, top. I'm sorry.
Here. Right? Or here. But your variable is somewhere in the top. Now, are you going to set up the law of sines on this problem? No. Therefore, do you have to worry about the possibility of an extra solution? No. Therefore, how many triangles are possible? One. The one you find when you set up your law of cosines and do all the work that you do, which you didn't have to do. The answer is 1. Okay, did everybody see that? So I snuck in some other problems there in that group, in that list. But the idea is you only have to worry about potentially 2 solutions if this is how you start your problem. If you're going to start your problem with the law of cosines, or if you're going to start your problem with the law of sines, but your variable's here, no issue, none. Okay, that clearer? Okay, Robert?
So the answer to one of those problems will be like 1 or 2. It will be like how many actual triangles
Yes.
you can have.
It's
Okay.
0, 1, or 2.
So if sine B is like that's what you're looking for, it means there's only one possible triangle.
No, no. That's when you have to check to see if, well, first of all, there might be none. Remember, sometimes we get an error message. But then if you get an answer, then you have to check to see if there's the second one. But that only happens in this scenario. That's the angle side case, which is the ambiguous case. It's ambiguous because you don't know what you've got. This is side angle side. I know exactly what I've got here. All right. Okay, well, good. I'm glad we talked about that. All right, who else found something that was a potential problem for you? Yeah, Brittany? 4A. Okay. Well, so this is a, all right, I want to find AC. Well, what are we talking about if we want to find AC? What is that? AC would be this diagonal right here. Now, as soon as I drew that in, Brittany, I got a triangle, right?
Figured the other two.
So, I'm looking for a piece of the triangle. That's always going to be law of sines or cosines, unless you have a right triangle, which we don't. So, which one would be appropriate? Given what I've been given in this scenario, which would be the appropriate tool? Cosines. And the law of cosines would look like what? You can help me out. I'll use x squared equals what? 14 squared plus, yep. Oh, don't forget the 2. Perfect. Again, some of us discovered on our quizzes the other day, we can get it all set up, but we can't type it in. So you might want to make sure you can type that in Don't forget, you always need to take the square root in one of these problems. All right. Is that okay, Brittany? Anybody else have something? Yes, Jenna.
For 1C, when I typed it into my calculator, I kept getting an error message. And I looked on your work and you had like the 0 with the slash through it. Is that just because it's just not a possible triangle?
Yeah, it means there's no triangle possible. Remember, when you have this setup and the variable is here, you could have no triangles, and your calculator will tell you that because it'll give you an error message. Or you could have 1 or you could have 2. So when the calculator says error, you might type it in again just to make sure you didn't make a mistake. But if it says error, that means there's no triangle possible. And that's going to happen sometimes with this setup. All right, anybody else? I'm looking at B, and it looks like B is another one where I kind of tried to trick you, because I'm such a sneaky devil. Would that be a law of signs problem? Yeah, would that be a law of signs problem? Yeah. So I'll set it up. Sine 24 over 6 equals sine 49 over S. Is that okay? How many triangles are possible? 1. I don't even need to work it out. Why? What happened here? The variable is not up here in the top. That's when I have the issue, remember? This is perfectly okay. I'm going to go ahead and solve that. That's going to be great.
So if the variable's down there, it's always 1.
The only time you have to worry about multiple solutions is when you set up your law of sines and your angle is the variable. Other than that, you never have, think about all the problems we've done. This never gives us any trouble. This is not a problem. This is angle side. That's not a problem. We can do that. This is where you have issues that you have to talk about. Anything else for pre-quest number 2? Yeah.
I'm still having trouble typing in the cosine that in my calculator and getting the right answer.
Okay. I want you to take your calculator. 14 squared plus 6 squared minus 2 times 14 times 6 times cosine 122 equals. Okay, then second square root, second answer. And it should be 17.917.
That worked out. I was chopping it up.
Don't.
All at once.
If the variable is over here, then everything's solved for. I mean, that's exactly what you want. So you just type that in.
Okay.
If the variable, like there's one of the problems where you had to use the law of cosines to find an angle. Which one was that? Number 5. Now those are a little bit tougher to type in. Not tougher, you just have to be more careful because the variable is not solved for already. Alright, so this one, this is number 5. It says find the largest angle. Which one would that be?
Wouldn't be the one from across this one.
Yep, it would be R. Everybody good on that? Okay, so we're going to find angle R. Would you agree this is a cosine problem? So which side is going to be over here by itself if I'm solving for angle R? So I'm going to have 20 squared. And then 18 and 16 minus 2, 18, 16 cosine R. Okay, is that set up all right with everybody? Now this is your variable now, so somehow you have to get him by himself. So this is a little bit, I mean, this one you might want to do in a couple of different pieces.
Solve it out first.
So we've got 400. I should know that. 3.
I think that's like, no idea.
It's 580.
When you add them together, it's what?
580.
So these two added together, 580. Are you okay with adding those together?
Yeah.
Alex, could you bring me a pass? Thank you. All right, so we add those two together, and then we times all these together. What do we get there?
576.
576. And this is where the issue comes in. We're all pretty good at that. See these two numbers right here? We'd love to subtract those, but we can't, can we? Instead, we're bringing this one over here, and then we're going to divide, right? And then we will second cosine that fraction or decimal, and that will give us angle R. Everybody okay with that? Okay, so we know what we need to know for the quest tomorrow. Hi, Mrs. Roby.
Is Anna here?
Uh-huh.
Anna, you need to be testing right now.
Oh, we're sorry. Anna grabbed my stuff.
Okay.
We'll see you tomorrow. Does she test tomorrow, or is this the only day?
No, this should be it. It'll take your full period, but hopefully not too much longer than that.
Okay, so everybody's great on what you need to know tomorrow. Okay, well then, what we're going to do is, today, we are going to begin the next little section, and we're going to split chapter 6 up again, because it's really in 2 distinct pieces. And the first piece of it is about vectors. So we're going to do a little bit of study of vectors. Now, not anything hugely in-depth, but we're going to talk a little bit about vectors. Anybody in physics know what a vector is? Well, if you put 2 vectors together, they would like make an angle maybe, but no, a vector is a directed line segment. Now, what does that mean? Well, think back to geometry. Did you talk about line segments in geometry?
Yeah.
So you know what a line segment is, right? If this is A and this is B,
Still long.
it would be just this piece. It wouldn't be the whole line with the arrows, it would just be this, right? And when you wrote that down on your paper, you wrote it like this, right? And some of you may have written it like this. And it didn't matter, because a line segment is simply that set of points. It doesn't matter whether you talk about A to B or B to A, it's the same set of points. Those are the same thing. In vectors, we're going to take that very concept. It has a length. It is a definite length. But we're going to add direction to it. So a vector going from A to B would look like this. Now, some people put 2 tips on the arrow. I prefer 1. Because in geometry, when you put two tips on the arrow, when you had something that looked like this, what did that mean?
Array.
That was a ray. And rays are very different than vectors. What does ray AB mean?
Line continues.
Ray AB means this, right? That's not a vector. A vector is a segment. It has length. It has a definite start and a definite stop. This is vector AB. And the order matters. Because if you said this, VA, what would that mean? It would mean the same length, but it would be going this way, right? So it's like the difference between going east and west. It's different. The length is the same, but it's different. Now, the study of vectors and matrices has its own vocabulary. I don't know why, for sure. I'm sure you can Google it and figure that out. But there are some very basic concepts that have bigger words attached to them. And we're just going to have to get used to those words. It isn't a big deal. Vectors have length. But in vector land, we don't call it length, we call it magnitude. So when you are asked to find the magnitude of a vector, they simply want you to tell you, or they want you to tell them the length of the vector. Okay, so let's do some examples. Let's suppose that we'll say point P has coordinates 1, 3, and Q has coordinates -4, 5. All right, I'm just making these up. These are random points. Can you find the vector coordinates, also referred to as components? Again, more vocabulary. We're not going to be confused by it. Find the vector coordinates of vector PQ and find its magnitude. Now, this is one of those problems that when you read it, man, you think, I'm smart if I can do this. This is a really complicated situation. It really isn't. I mean, you are smart, but this is easy. Vector PQ, his coordinates. And we're going to write them like an ordered pair. Some textbooks write them like this. And the reason they use that notation is to distinguish it from an ordered pair. When I see this, I recognize, just because the way it's written, this is point P. This is a point. But down here, that same notation is going to represent a vector. Now, this is the vector that starts at P and stops at Q, right? So think about this. Pretend you're a little man and you're going to walk from this point to this point. Look at the x's first. You're going to walk from 1 to -4. What is that? How far is that? 5. Is that 5 in the positive or 5 in the negative? Negative. So the x coordinate, or the x component of your vector is -5. This movement goes back 5. Now what about the y's? What's going on with the y's?
It's up to.
Up 2. So the coordinates of that vector are -5, 2. Easy enough? All right, before I do the next step, let me just do another example over here. Let's just make sure we've got that part of it figured out. Let me get a couple more points. Let's say S is -5, 7, and T is 0, 3. Can you find, right now on your own, can you find the coordinates or the components, whatever the word you want to use, for the vector from S to T? Take a minute, see if you can do that. Think about walking from -5 to 0. and then from 7 to 3. How is this vector moving? Anybody want to hazard a guess? Dan?
5 negative.
He says 5, -4. Anybody want to argue or agree, disagree? You voting with Dan?
Yeah.
Okay, so that's pretty easy, right? Okay. If by chance, it didn't happen, but if by chance I would have gotten the same coordinates for these two vectors, I would have called them equal vectors. Clearly they would have different start and stop points, but if they're moving the same way, they're equal. So if you have two vectors that are -5, 2, then they're equal. They have the same motion, the same direction, the same length. These two are clearly not equal. Now I want to talk about their magnitudes. Now what does magnitude mean again? Okay, so let's take a minute and get some ideas from you. What are your thoughts on maybe, let's come back to our first example. I know this vector starts here and stops here, and I want to find its magnitude. Any ideas about how we might do that? Jamie?
Look at the x coordinates and then like do what you did there minus x coordinates.
For the magnitude? I definitely want to use the x coordinates, but I think we need to involve the y's too. Oh, the distance formula. Let's think about what the scenario is. You've got 1, 3, here's point P, and Q is -4, 5, and here's our vector, right, if we actually drew a picture of it. Isn't the magnitude just the distance between those 2 points? So Jamie says let's use the distance formula, and that's all well and good for those of you who remember the distance formula. Anybody remember it?
X1 minus, or Y1 minus 1.
This is my proudest moment as the chairman of the math department at Cathedral High School.
Give me a try, I'm gonna go with Y1 minus X1.
Brittany?
x1 minus x2 squared plus y1 minus y2 squared.
Yes. Good job. Thank you all. All right, so we subtract the x's. 1 minus -4. We subtract the y's. 3 minus 5. We square those and add them up. Please tell me that looks familiar, people. We probably should not be forgetting the distance formula, but so let's kind of maybe file that away. That's kind of a biggie to remember. So what do we end up with? 1 minus -4 is 5 squared is 25.
Plus 4.
3 minus 5 squared, that's 4. So our answer is
Square root of 29.
square root of 29. The magnitude of the vector is the square root of 29. All right, how about this one? Let's do this one. What's the magnitude of this vector? -5 minus 0. 7 minus 3. So we end up with, doing the arithmetic, 25 plus 16, that's the square root of 41. Everybody okay with that? Now I want to show you something, because you're not always going to have the coordinates. I'll show you what I mean when we do a couple more examples. You're not always going to have the coordinates of the ordered pairs. You're not always going to have the actual start and stop point. Sometimes all you're going to have are the vector coordinates. I want you to notice in both the problems we did, take a look here. What would happen if I simply squared the components of the vector and added them together and took the square root? In other words, 25 plus 4 and took the square root of it. What would happen? What would I get? I get my answer. What would happen over here? We figured out these were the vector coordinates. Square, square, add them up, square root. Do I get root 41? Yes. So if somebody says to you, vector u has coordinates 3, 5, what is the magnitude of vector u? You will say it's the square root of 9 plus 25, or the square root of 34. Now I've used a couple of notations. I've snuck some stuff in that we need to talk about. Notice when I wrote my coordinates, I said vector ST. But when I did my distance formula to find the magnitude, notice what's missing.
Magnitude symbol?
There's no
Vector symbol?
vector symbol over it. When all you have are the letters, that means the distance. And we talked about that way back at the beginning of the year. That means the distance. So when I did my magnitude, I just used the letters PQ. Then up here, what notation did I use to indicate magnitude? I didn't have letters. I didn't have an A and a B or a P and a Q and R and S. What notation did I use? Absolute value. And that's magnitude. That means magnitude. So your magnitude notations are either the plain 2 letters, if you happen to have the letters, or the absolute value notation. That always means find the magnitude. Okay? All right, this is so critical. We're going to do a quick recap here, make sure everybody can do it. So try this one on your own. Point C is -4, 3, D is 1, 4. I want you to find the coordinates of the vector and find the magnitude of the vector. See if you can all do that, and then we'll move on to the next step. Coordinates? Quickly, did you get coordinates? What'd you get? 5, 1, you said? Everybody agreed? Positive 5, positive 1? Beautiful. John, did you get magnitude? Jack, did you get magnitude? 326, perfect. Everybody's good? So ready for the next step. All right. Let's suppose that you have some vector out there. Now notice, this is not an ordered pair. This describes a vector going -3 in the x direction, 1 in the y direction. And you got another one that's moving like this. So if I wanted to draw a picture of vector u, one way I could draw it would be like this. Now there are lots of ways to draw that vector, but one way would be just to start at the origin and say, okay, this guy moves left 3 and up 1. Do you agree with that? Okay. And then V, if you wanted to draw V, it would look like this. It moves over 5 and up 4. You all right with that? And if I said to you, find the magnitude, everybody would know how to do that. You just did it. But I don't want you to find the magnitude now. What I want you to do now is add these 2 vectors together. you've never done this before in your life, probably. If somebody were saying to you, I'm going to leave you on this desert island with no food and water, unless you can add those vectors together, what would you do? What would be your gut instinct? You'd have no idea what to do, but what makes sense? Oh! Someone said it. Add the x's, add the y's. The sum of these two vectors would be 2, 5. That's all there is to it. It makes perfect sense. You want to add them together? You want to know what the total movement of this is, these two vectors put together? If this one goes back 3 and this one goes forward 5, then the result of that would be forward 2. Does that make sense? And in fact, the sum of two vectors has a special name. It's called the resultant. It's the result of what happens when you add two movements together. Resultant is simply the vector word for sum. So when someone says to you, find the resultant of these two vectors, all they want you to do is add them together. And how do we add them together? We add their x's and we add their y's. Right, how about this? Oh my. Now I'm getting wild and wacky. We know what U is. And we know what V is. What am I going to do with that 2? Distribute it. That probably isn't the right word to use, but it's exactly the right concept. We're going to take that 2 times both of those. Think about it for a minute. Think about it. V is the vector that goes right 5 and up 4. What would 2V do? Go right 10 and up 8? Doesn't that make sense? So we have negative 3, 1 minus 10, 8. All that 2 does, here's vector V right here. What does that 2 do to it?
Double it.
Double it. Makes it twice as long. So instead of going over 5 up 4, it's going to go over 10 up 8. And then what do you think the answer is? Are you ready to take a wild guess at that? Watch your arithmetic. What is it? Negative 13 and negative 7. Remember how we added? We added the x's and added the y's. How do we subtract? Subtract the x's and subtract the y's. Same thing. Jamie? Yes. Yes. Because technically, Jamie, subtraction is nothing more than adding the opposite. So this is an addition problem too. Subtraction is just addition with a negative. Now there's another vocabulary word I need to throw in here. When you saw that 2 right there, what did you think of him as? A coefficient, right?
Yeah.
Well, in vector or matrix land, we don't call them coefficients, we call them scalars. He's a scalar. So what is a scalar? A scalar is simply a real number. U is a vector, V is a vector, but 2 is simply a real number. It's called a scalar.
A lot of vocab today.
A lot of vocab. Yep. Lucky for us, the language will carry over into matrices too. But yeah, this is new vocabulary. We got it? Okay. All right, let's try the next one. In vector land, It is often wonderful to have vectors whose magnitude is 1. Now what does that mean? What magnitude is length? So we like vectors who have a length of 1. Now you are already very familiar with some of those vectors. Talk about your handy dandy unit circle. Oh yeah, you don't go anywhere without your unit circle. This is a vector, and how long is it? 1. That's called a unit vector. A unit vector has a magnitude of 1. This would also be a unit vector, wouldn't it? In fact, any vector I draw in that circle would be a unit vector. Its magnitude would be 1. It's a radius. It would have a magnitude of 1. Those are so special. Unfortunately, when we're out just walking through the hallways, most of the vectors we find do not have a magnitude of 1. So we often want to find a unit vector in the same direction as the vector that we have. So let's say vector A has coordinates 3, 4. Now again, what does that mean? That means that wherever vector A is, it marches 3 units to the right and 4 units up. Right? What's its magnitude? Well, you have to figure it out. It's 5. Let's refresh our memory. Some of us forgotten already. How do we find the magnitude of a vector if all we have are its coordinates? Do square, add them up and take the square root. So that happens to be 5. So I'm going to draw a picture of this because we need to figure out how to make that a unit vector. And then I'm going to shut up for today because we've had quite a bit of information and we have a quiz tomorrow. So I'm going to be ready for that. So let me draw a picture of this. There he is. You just told me that he's 5 units long. And I believe you completely because if I go over 3 and up 4, that would be 5, right? Now, I want to make a unit vector, though, in the same direction. So I want to talk about that guy right there. His length is only 1. Does anybody have any idea what his coordinates might be?
1, 1, 1, 2.
Now, let's talk about that. 1, 1, root 2. Would 1, 1, which is what I just drew here, would that be a unit vector? Be careful. What does it mean to be a unit vector? It means your magnitude is 1. What is the magnitude of this vector? Square root of 2. So that is not a unit vector. It's a good guess, but that is not a unit vector. Pretend that you had a shrinking machine. You know how you zoom in and out? I don't know which way I'm zooming here, but I want to shrink this thing, okay? I want this length to be 1. So in other words, I want to shrink this thing by a factor of 5. Instead of being 5 units long, I want it to be a 1/5 of that. I want it to be only 1 unit long. So what would this be? If this is going to be a 1/5 as long, then this side would also have to be a 1/5, which would mean this is how long? 3/5. And this would be how long? the coordinates of your unit vector are 3/5, comma, 4/5. Now, I don't know if that makes any sense to you at all. We simply took what we had and fifth it. Now, why, of all the numbers in the world, did I pick the fifth
That's the
it?
distance of it.
Because that's the length of the original, exactly. If the length of the original had been 6, then what would I have done? Divided by 6. If the length of the original had been 10, I would have divided by 10.
So it's just always that.
You divide by, yeah, the hypotenuse is going to be the magnitude, and you divide by the magnitude. Yep. Yep. All right, that is where we're going to pick up tomorrow after your quest. All right? Now, here's what I want to do. I am not assigning any official homework tonight. However, I am assigning a large chunk from section 6.1, which is what we've been talking about. We haven't finished it yet, but there's a lot in there. So I'm going to give you all the problems, and they are going to be due on Monday. Okay? So if you want to wait and do them all over the weekend, that's fine. If you want to get a head start, here they are. Tomorrow we have a quest. You will need to go back if you have trouble typing things in or doing whatever you need to do. You'll take care of that tonight. But here is the 6.1 assignment. This is due Monday in its entirety, and there is a lot. Okay? And again, you should be able to do these first few. So if you want to crank those out tonight or in your remaining 6 minutes here, that is absolutely fine with me. If you want to wait and do it over the weekend, that's fine too. Everybody clear on the assignment expectations? Okay, you got a little time. Let's get started. I need to take attendance. I haven't done that yet.
So if we can do the pre-quiz, that was the homework last night, should we be able to do the quiz?